Hello students. So in this video, we'll talk about revision, okay, revision questions for your upcoming unit tests. So this is for grade 7 maths, and the topics that we will be discussing are integers and fractions. Okay, we have seen the properties of integers in the classroom sessions. We have seen BODMAS, we have seen closure property, we have seen commutative, associative, distributive property, applications, we have seen fractions, we have looked at addition of fractions, subtraction of, operator of, division, and then a few word problems as well. Yeah. And also in integers, we talked about the reciprocal or multiplicative inverse, the additive identity, and so on. So we'll see a few questions as part of your revision today in this session. All right. So let's start with the first question. If I like as I share the model with you earlier, if you can go back to the model, there are 6 MCQs, 6 1-mark questions, 6 1-mark questions, and each of them have options A, B, C, and D. So you will just be writing the right question number and you'll be writing the right option. So against 1, what is the correct option? Against number 2, what is the correct option? Okay, so we'll see this. Let's start off with the first question under 1 markers. See, remember the options are given. So you have to solve and then choose which is the right option. Okay. So remember, your working is not going to be seen here. No matter how many steps of working you have, you have shown. Finally, it's the final answer that counts, which means marks are not given for individual steps of working, and it's only for the final answer. All right. So let's start with the first question under 1 markers. Let's say I give you a sum like 13 divided by 1, okay, or 13 divided by minus 1 in integer form. In integer form is. So there'll be 4 options. Option A, option B, option C, and option D. Option A is 1 by minus 13. Option B is minus 13 by 1. Option C is minus 13. And option D is 13. So in integer form, what will it be? So the correct option is option C. Now why is it? See, if you look at minus 13 by 1, 13 by minus 1, whatever is given to you, that is the question. I want the integer form, right? Now it is in the form of A divided by B. It is in that form. Now, I told you 13 by minus 1, you can transfer the negative sign on top. It becomes minus 13 by 1. And when you have 1 in the denominator, it is redundant. You can ignore it. You can leave it out. So that becomes minus 13. And so your option is C. So none of the other options are correct. So when you write your final answer in the paper, you'll be writing 1, option C. Okay. So let's move on to the next question. Okay. Next is 17 divided by minus A is equal to 17. So therefore, A is equal to option A, option B, option C, and option D. A is equal to 1, option B minus 1, option C 17, option D minus 17. See, if you have a look, you see that all the options are like confusing, isn't it? They all look somewhat similar, close to each other. Sometimes more 2 options look quite the same. You're left wondering whether this is A or B or C or D. So what you have to do is you remember you have to go with the laws here. So when you have 17 by minus A is equal to 17. So what values can A take? Isn't it? If I want 17, so I have 17. I told you, if you write A divided by A, it is equal to 1. Or A divided by 1 is equal to A. Now, if you look here, what do you have here? You have 17 here and you have 17 here, isn't it? Compare it with this form. So it can only happen when down you have 1. Look here, you have minus a. 17 by minus a will give you 17. That means this bottom portion I need to have 1. I need to have 1. So a will be minus 1. Minus of minus 1 can give me 1, isn't it? So if a is minus 1, minus of minus 1 is 1. So that 17 by 1 is equal to 17. The correct option is minus 1. It's very confusing. You might be tempted to put option A or maybe C or D. So be very careful. You can do a lot of these things mentally. MCQs, the options are given. You can do it mentally, but be very careful, because sometimes, because exams or tests are time bound, and in the pressure of solving you might, even if you know something carelessly, you might write like this. So you need to be careful about it. So a is minus 1, because minus of minus 1 will be 1. So 17 by 1 is equal to 17 divided by 1 is 17. Okay. Another type of question that you can expect is, yes, coming to additive inverse. See, if I have to draw a table. Okay. In the classwork sessions also, I made you, um, you know, multiplicative and additive inverse, multiplicative inverse. So I made you fill up this table and I told you it is very important. See, multiplicative inverse. Multiplicative inverse, it's also called as a reciprocal. So now we are dealing with integers. So if I give you a number 3, its additive inverse is, wait, let me erase this. Okay, it's fine now. So the additive inverse of 3 is minus 3. Number means, let me say integer, because this chapter is dealing with integers. I didn't go beyond integers, so let me stick with integers now. So what is the additive inverse of 3? Minus 3. What is the multiplicative inverse? 1 over 3. For additive inverse, there is a sign change. That is, plus becomes minus, minus becomes plus. For multiplicative inverse, it's the same sign. If it is plus, it remains as plus. If it is minus, it remains as minus. Additive inverse of, let's say, 7 is, if I say additive inverse of minus 7, if I give you integer minus 7, what is its additive inverse? Plus 7. Okay. And its multiplicative inverse will be 1 over minus 7, or we can also say minus 1 upon 7. I told you this. Now, if I give you, let's say, 1, what is its additive inverse? It is minus 1. And what is its multiplicative inverse? 1 over 1, which is 1 itself. So the multiplicative inverse of 1 is 1, and the additive inverse is minus 1. Same thing for minus 1. What is the additive inverse of minus 1? Reverse. It is plus 1. And multiplicative inverse will be 1 over minus 1, which is minus 1 by 1, or 1 minus 1 itself. So remember, in the universe, there are only two numbers which have the multiplicative inverse as themselves. Like for 1, the multiplicative inverse is 1 itself. And for minus 1, the multiplicative inverse is minus 1 itself. Should be very clear about it. And what about 0? Please remember that division by 0 in the system in maths, it's not defined. So additive inverse of 0 is 0 itself, because 0 plus 0 will give you 0. But multiplicative inverse is 1 by 0, which is not defined. You cannot divide anything by 0. So division of by 0 is not defined. In other words, 0 has no reciprocal. It has no multiplicative inverse. We need to be clear about it. Okay. And then we'll go on to the next type of question. It's pretty simple, provided you know your tables and you understand the properties of integers. See, if I give you something like 158 into, let's say, dash is equal to minus 158. Very simple, you'll write minus 1. Pretty simple about, nothing big. Let's say 15 into dash is equal to minus 120. You should say minus 8. So here, even if you put plus 8, you will not get the answer. Please be very careful of the signs. Plus into minus is minus, minus into plus is minus, minus into minus is plus, and of course, plus into plus, we all know it is plus. So you should know this. So you should know like what should come in the place of the blank. This is the type of question that you can be asked. You can be given 4 options, or you can be asked to just fill in the blanks. Next, I'll give you another type of question where it's an MCQ. The greatest fraction is. The greatest fraction is. So it can give you like 19 by 29, 19 by 25, 19 by 100, and 19 by 17. So when you look at this, uh, what do you observe in all of these fractions? Maybe this is option A, option B, option C, option D. Which is the correct option here? Numerators are same. When the numerators are same, larger the denominator, smaller is the fraction. Or smaller the denominator, larger is the fraction. Now, if you see all of them, it's 19, isn't it? Numerator is 19. Look at the smallest number which is in the denominator. It is for option D, isn't it? So when the numerators are same, smaller the denominator, greater is the fraction. It is 19 by 17. It's simple. What you say, concept-based question. There's nothing to really calculate. You should know the knowledge that, if the numerators are same, if the denominator is large, denominator is small, I mean, the fraction is large. And the other way around, the denominator is large, that fraction will be small. Okay. So this is a type of different type of 1 mark question that you can expect. Now, you should know these. See, remember children, a lot of this that you learned today in 7th grade, you are going to apply it in 8th, and 8th you'll be applying it in 9th. Okay. So it's going to help you in that way. So you should know what is additive inverse, what is multiplicative inverse. So directly you might be wondering, where am I applying right now? Remember, you're giving a test to assess your knowledge. The test will be easy. It will be based on whatever we have done and whatever I'm doing in the revision. Some of you asked for online classes, and I told you that since all of them may not be able to join, I thought this is an alternative. I hope this is going to help you. This will definitely help you. So you should know that. You should know the rules and the laws that we have covered in the notebook in the classwork sessions. Yes, all the laws, commutative law, and then the law of distributive law. Distributive law is also very important. I'll come to that now. So coming to when I was speaking about distributive law, this sum came to my mind. 2 markers. So if I give you a sum like this, it's 2 markers. See, 2 in 1 markers, it's just one blank that has to be filled up, or the correct option that has to be mentioned, option A or B or C or D, like that. But in 2 markers, you have to show minimum 2 or 3 steps. Yes, you can't just do mentally and say, I did it in my mind. Okay. See, mind calculation is very important. Mental mathematics is important because you're processing it in your brain with shortcuts and tricks. I've taught you a few tricks also in the class. But when it comes to exam, I told you it's execution, isn't it? It's not an oral exam. You have to write out the steps. You have to write down the steps. You have to show it out to see, when I see the paper, I should understand that this child knows the logic, the methodology. So 2 markers, one type of question that I told you, that distributive property where we are going to show that is, let's see, let's say 875 into 101 minus 875. So this you have to solve using distributive property. See, in Indian system of education, I told you no calculators are allowed. It's very important. It's good also because that you learn to learn to be less dependent on technology. Yes. See, we will use calculators later on in life. When you grow up higher, you'll be using scientific calculators. I told you now it will not be allowed. So you have to know basic tricks, shortcuts, and properties. So this is the property of integer here, which is called distributive property. When a sum is given like this, what you should do? 875 into 101 minus 875 into 1. See, when I give you any number A, I can write it as A into 1, isn't it? So I'm going to use that here. So, and, take out 875 common. If you can recall, what is it? A into B minus A into C is what, children? A into B minus C. This is distributive property over subtraction, isn't it? You can have it over addition also. So, now, in the same thing, you relate to this sum, 101 minus 100. B is like 101, C is like 1, and A is like 875. So in the brackets, let us simplify first. What is 101 minus 1? 100, isn't it? So it is 87500 or 87,500. You can put a comma as per Indian system of numeration. So this is it. So it's very simple, isn't it? Otherwise, you have to calculate 875 into 101. The calculator will do the job in just a matter of seconds. But I told you, you have to learn. You should know, isn't it? You should know the methodology. And that's why we have teaching you this And I have taught you this, and you'll be tested on one such topic related to distributive property. Now let's move on, children. Next sum is, when I ask you like, let's say, compare and say which is greater. See, remember children, when I give you two fractions, I told you you can use cross multiplication. You can use LCM method also, but cross multiplication is something uh, that is easier, and you can use that when there are only two fractions involved, this or that. You have to put the greater than symbol, isn't it? Maybe it will be greater than or equal to or less than. See, if I give you 3 by 4 and I give you 12 by 16, obviously, when you compare, what will you get? 16 threes are 48, 4, 12, cross multiply, isn't it? Numerator of one with denominator of the other, why the other way around. 12 into 4 is 48, isn't it? 12 fours are 48, 16 threes are 48. I hope you can remember your tables. I had been telling you from day one, remember your tables, because otherwise, this becomes difficult for you in the exam. You'll have to spend a lot of time. You should know up till 20 by now. Okay, 7th standard children. So now see, 16 threes are 48, 12 fours are 48. Both sides it's same, isn't it? So we will put an equality sign. But that means the fractions are equal in value. We say equivalent fractions. If you can remember, I told you they are not equal. Their values are equal. See, 3 and 12 are not same numbers. 4 and 16 are not same numbers. But when 12 by 16 boils down to finally 3 by 4, isn't it? Its value is the same. So equivalent fractions, when the value is the same. But what if they are not equivalent? Then we have to, another method. For example, if I give you 30 by 40 and 50 by 60, and I'm asking you which is greater. So, if you see, they have zeros in all the places, isn't it? You can still compare it as 3 by 4 and 5 by 6. So, you can cancel out the zeros in all of these, and it is as good as comparing 3 by 4 and 5 by 6. We'll adopt the same cross multiplication technique here. 3 into 6, let me do. What is 3 into 6? 18, isn't it? And this side, 5 into 4. Numerator has come from here. 5 into 4 is 20. Which is bigger? Obviously 20, isn't it? 18 is less than 20. The open mouth means the greater symbol, right? So this open mouth of that symbol shows that 20 is greater. So 20 is relating back to 5 by 6. So we'll say 3 by 4 is less than 5 by 6, or 5 by 6 is greater than 3 by 4. Yeah. So this is simple way to calculate which is a greater fraction. Now remember, when you have more than 2, you can't do this. You have to go with the traditional method that I told you, which is our LCM method. We'll come to it. So now let's look at another problem. Let's say I'll give you two expressions. Okay. So I'll say I will give you an expression like -3 plus 13 and -15. And I'll put a big box here because you have to put the symbol, right? Symbol of comparison, whether greater than, less than, or equal to. And on the right side, you have an expression like 25 -2, okay, plus -33. See, always I told you, go with BODMAS. Whatever is in the brackets, you will simplify first. Then, of course, it will always be BODMAS. If you can recall, first in the order of the priority, it decides the priority. Okay, the order of precedence, brackets. Then it's your of, then it's your division, multiplication, addition, and then subtraction. So look at your left-hand side. Then look at your right-hand side. On the left-hand side, you have 13 minus 3 is 10, right? And 10 minus 15. And 10 minus 15 is -5. Okay. And look at your right-hand side. So you have minus of minus here, isn't it? Which is plus, minus outside. And so it changes to plus, -33. So the addition is performed first. 25 plus 2 is 27. 27 minus 33, which is -6. See on the number line I told you, remember, 0. Then you have 1, 2. Then you have -1, -2, like this, isn't it? So left, right. So left is this. Left means less. LESS, LEFT, I told you. When you go right, it is MORE, more. Right means R is coming here, isn't it? So always when you go away this side, it is more. When you go towards the left, it is less. So when you compare, if I draw my number line, I'll just write it. 0 is here, okay? 1, 1, 2, 3, 4, 5, 6, 7. So -1, -2, -3, -4, -5, -6. See, where does -6 come? -6 is to the left of -5. 6 is greater than 5 because 5 will be written here. Then you have, see, 4, 5, and then 6. But here, if you look at negative numbers, when you compare to negative integers, see, -6 is to the left. And always what is left is less, isn't it? So -5 will be less or greater. Greater. -5 is greater than -6. Remember, 5 is less than 6, but -5 will be greater than -6. It's simple. What is on the right? When you actually visualize the number line, or even can draw the number line also, if you're getting confused. So you can observe that whichever number is on the left, it will be lesser, and the number on the right is always greater. So obviously this calls for this common understanding that 0 is always greater than every negative integer. 0 is less than every positive integer. And always every positive integer is greater than every negative integer. Okay. So I hope this sort of sums are clear to you. And the next is simplification. Yeah. If I give you a fraction like 36 upon 56, for example, and I ask you to simplify it. See, it is left to you. It's always good to know the HCF of 36 and 56, the highest common factor. Okay. So if I know, or I should do division by 2, both are even numbers. Okay. So I can successfully divide by 2. But better is if you know the highest common factor, it becomes a lot easier. For example, I can write 36 as 4 into 9. And I can write 56 as 4 into 14. See, if you remember your 9 tables and 14 tables, 9 fours are 36. 14 fours are 56, isn't it? So that's why I always keep telling, if you know your tables, it becomes easy for you to compute. You can do it very easily. And you can know which number will cancel out, whether it's division, multiplication, etc. And even when you take LCM and perform the addition, subtraction of fractions. So please learn your tables well. And now you know that when you write this way, you can cancel out the 4 and the 4. And you'll be left with 9 over 14, nothing common to them. And the answer is this. The simplified version of 36 by 56 is 9 upon 14. Okay. Next, moving on, let's go on to another type of sum where which is a 3 marker. So we have covered different types of 2 markers. 3 markers, what happens, children? I'll give you a sum like this. So I'll give you some fractions because the topic is fractions, isn't it? 4 by 5. Then I'll give you 11 upon 15. I'm just giving you some fractions. It's for practice. And then 17 upon 20. Okay. And then finally, it will be 7 upon 10. And compare. I'm telling you, compare. Or differently, I can word it. I can say arrange in ascending order. Ascending means, what is ascending? Low to high, isn't it? Low to high, like aeroplane. A for aeroplane. It's going up from low to high. Descending is high to low, isn't it? From high to low, you're going down. So look at the question carefully, because if it asks ascending order, you have to arrange them from lowest fraction to the highest fraction. Descending will be the other way around. So for all of this, of course, you have to, you need your LCM. So let me just, put some, I told you how to do these kind of sums. Put some nice borders out here like this. And let's find the LCM. 5, 15, maybe I can write it in order. The denominators, children, take out all the denominators, 5, 10, 15, and 20. And then now I'm going to, so 5 1 goes 1 times, 5 goes 2 times, 5 goes 3 times, and 5 goes 4 times. Now just bring the 1 down. What about the 2? 2 goes 1 time and 2 goes 2 times. then both are 1, bring them down, then 2 goes 1 time, and finally 3 goes 1 time. So we are left with all ones, and up till there we have to go, isn't it? So then now just take down all of these. 5 into 2, 10, 10 2s are 20, 23s are 60. There you go. The LCM of all these numbers is 60. Okay, the LCM is 60. So this is, you anyway, you've learned it in your grades 5 and 6 how to take the LCM. You learned it earlier. It's nothing new, but I'm just showing it to you here. So now, so we will just write them. Okay, 4 by 5 is equal to dash by 60. So we have converted all the fractions to fractions with the denominator 60. In other words, we made them like fractions. Remember, like fractions means fractions with the same denominator. Okay, so dash by 60. So now it's just a simple calculation. 5 into what will give you 60? 5 12s are 60, isn't it? If you can remember, 5 12 5s are 60, or 5 12s are 60. So you multiply 4 also with 12. 12 4s are 48. Okay, now write it neatly here. 48 upon 60. Okay, 11 upon 15. 15 will go how many times into 60? 15 4s are 60, isn't it? 15 into 4 is 60. Now I'll write it down here. So multiply the numerator 11 by 4. 11 4s are 44. So we'll write it down here. 44 upon 60. Now 20 will go how many times? 2 3s are 6. 23s are 60. So what happens, children, here? 17 3s are 51. Very good. So 51 upon 60. Finally, 10 6 are 60. So 7 6 are how much? 42. So 42 upon 60. So now, when the denominators are same, they are all like fractions. And how do we compare? If the numerator is larger, the fraction is larger, isn't it? When denominators are same, look at the numerators. Larger the numerator, larger is the fraction. So by this logic, suppose I say ascending order, what should I do? The smallest one I should put first, isn't it? Ascending means low to high. So the smallest fraction is which one here? Obviously, 42 by 60. I'll call it as number 1. Next, which is the next one? Next number is 44, isn't it? 44 upon 60, number 2. Next, obviously, number 3 and number 4. Okay. See here what we have done. I hope up till here it has been clear to you. You have to take the denominators and take their LCM, and then you have to convert that fractions to fractions with the denominator as 60 here with the LCM, isn't it? Okay. So from here, now what do we know now? We have to number them. So I numbered them 1, 2, 3, 4. The smallest one as number 1, the next one as number 2, the next one as number 3, and the largest one as number 4. You see, they have given you 4. They can give you 5 or 3 or 7 or any number they can give you, isn't it? But now, for now, just understand we can give you 4 fractions to compare. Even if you give you 3, the same technique, 3 fractions if I give you. If I give you 2, of course, remember cross multiplication helps there. Okay, so ascending order, we write the smallest one first, isn't it? 42 by 60. But what is 42 by 60? Remember, it is going back, it is 7 upon 10, isn't it? Then which is the next one? Which is the next fraction? Number 2 is 44 by 60, which is that 11 upon 15, right? That. Then third one is 48 upon 60. That is nothing but 4 upon 5. The original fraction is 4 upon 5. The converted form is, the equivalent form is 48 by 60, isn't it? And the last, the fourth one, the highest one is 51 by 60. Okay, and we can write like this. See, this is 7 by 10, 11 by 15, which is the smallest one, 7 by 10. So it is smaller. The next one is 4 by 5. 4 by 5 is less than 51, 51 by 60. Sorry, I have tried the original form. 51 by 60, what is the original form? It is 17 by 20. Okay. So that is 7 by 10 will be lesser than 11 by 15. Next one is less than 4 by 5 and less than 17 by 20. If they say descending order, this is ascending order. Okay. If it is descending order, it will be the other way around. And I will just write it as this is ascending order. Descending order means what? Descending order will be, just write it in the reverse order. 17 by 20 greater than, it will be greater than what? 4 by 5 greater than 11 by 15 greater than 7 by 10. Just reverse the order and reverse the sign. That's all. Because the greater one, open mouth is always towards the greater one, isn't it? In that symbol, greater, lesser, always. Remember this. Don't get confused. Okay, children? So you should know how to solve these. The LCM is very important in these cases. Then obviously, the last type of question is simplification, where you can have 6.5 plus 3, 1/4 minus 5, and let's say half or something like this if I give you. So there are different ways of doing it. You can add the whole numbers, because what is 6.5? It is as good as 6 plus half. You can do it that way. Otherwise, you can also convert each of them to improper fractions, isn't it? You can convert improper to mixed and mixed to improper. Okay, let us convert this improper mixed fractions to improper. 6 2s are 12 plus 1, 13 upon 2 plus 3 4s are 12 plus 1, 13 upon 4 minus 5 2s are 10 plus 1, 11 upon 2. Okay. Now, I told you when one number goes into the other number, exactly the higher number is the LCM. You can solve also 2 and 4, no, denominators. 2 1s are, 2 2s are, 2 1s are. Denominator is LCM of, we take 2 into 2 is 4. So 4 plus 4. So you made the denominators as the LCM. 2 will go how many times? 2 times. So 13 2s are 26. 4 will go 1 time. So 13 1s are. So 13 1s are 13. And 2 will go 2 times. 11 2s are 22. So we'll just try to solve them. So you can take the common 4. 26 plus 13 minus 22. You can apply BODMAS also. You'll be getting 17. Otherwise also 26 plus 13. Isn't it? 6, 7, 8, 9. 2 plus 1, 3. Okay. Minus 39 minus 13. You can, sorry. 2 plus 1, 3 minus 22. So we have first what we have done. We have added by 4. Okay. We have added these two. So we'll get 9 minus 2, 7, 17 by 4. Or, you can even do it directly. See, if you take 26 minus 22, you will get 4, isn't it? And 13 plus 4 by 4, which is 17. That also you can do, just for you to remember. But you can go with this. So 26 plus 13 minus 22 upon 4, which is 39 minus 22 upon 4, which is 17 by 4. See, 17 by 4. In ICC, what we do, mostly they expect you to convert it to mixed fraction. You can leave it at 17 by 4 for now. But, when you go to 8th, 9th, and even 10th, they want it in the particular format. Specifically, they say mixed fraction. Okay. So unless it's a ratio-based sum or something, it's usually advisable to put it into a mixed fraction. 4 4s are 16. 1 is the remainder. 4 is the denominator. Okay. So I hope up till here, it has been clear to you. So remember, children, always apply BODMAS. And then whenever you have a doubt, just write that BODMAS. So that confusion is gone. Where I say 6 divided by 2 minus 5, okay, into 3. For example, so you can perform this first. 6 divided by 2 is 3. Minus, now you can perform this because you have 5 into 3. Multiplication precedes subtraction, because multiplication then subtraction. No? 3 minus 15, which is minus 12. Okay. So if you, especially, to avoid ambiguity, whenever we pose any question, we put brackets. If I want you to perform a particular operation first. But if brackets are not there, then we have to go with a generalized rule. And for that, we have to adopt BODMAS. Remember this. BODMAS is very important. And we have different kinds of brackets. So you just have to know that square brackets, then you have this curly brackets, then you have the small brackets, and you have the bar or the vinculum brackets. So I hope up till here the explanation has been helpful to you. So learn well, prepare well. You just have been given two chapters for this upcoming UT. Prepare well. So we have done in detail several problems, different types of problems. I told you, it is not about how many problems you solve. It is how many different types of problems you solve. That is why we have not sat with solving hundreds of problems. But even if you solve 10 problems of different types and understand them, that is important. That is enough. No point in doing 100 problems of the same type. It will lead you to nowhere. I hope it has been helpful to you, children. All the best, children. I know that you'll all do well. Okay. And any doubts, you can always get back to me. We have formed a group, so you can always reach out to me. Okay. So all the best, children. Take care.